Hi, my name is Regina Tumarong from STEM 12G IT Nursing. This video is all about to know the individual values of series and parallel capacitor or series and parallel resistors. But first things first, we need to define these following words, which is first the capacitor, second the electrical circuits, third the electrical charge, followed by the voltage and current, then resistance, and lastly is the electrical power. So what is capacitor? So capacitor is a two-terminal electrical device that possesses the ability to store energy in the form of an electric charge. Second is the electrical circuit, is a path for transmitting electric current. Third is the electrical charge. So the electrical charge is the physical property of matter that causes it to experience a force when placed in an electromagnetic field. Next is the voltage. So voltage is a quantitative expression of the potential difference in charge between 2 points in an electrical field. Followed by the current. Current is just the rate of flow of electrical charge. Next is the resistance. Resistance is a measure of the opposition to current flow in an electrical circuit. And lastly is the electrical power. Electrical power is the rate per unit time at which electrical energy is transferred by an electric circuit. So we have here a battery, which is a parallel capacitor. So as you can see, we have the first example, and the first question is, the first thing we need to know is the equivalent capacitance in this circuit. So for these parallel circuits, the equivalent capacitance is the sum of all the capacitors connected in parallel, or add the two capacitors, and then we will get 300 microfarads, just like this one. CEQ equals 100 plus 200 equals to 300 microfarads. So next, how much charge is stored in the first capacitor? So to calculate the charge, just like this, we need to use this equation, which is the Q1 equals C1 times the V1. So the value of C1 is 100 times 10 to the power of negative 6, then times to the volt, which is the 15, and we will get 0.0015 coulombs. And proceed to the third question. What is the charge stored on C2? So just like the first example, use these equations, which is the Q2 equals C2 times V2, and then equals to 200 times 10 to the power of negative 6 times the 15 voltage equals 0.003 coulombs. So next, get the total charge. So the total charge is, as you can see, to get the total charge, we need to use this QT equals Q1 plus Q2. So equals 0.0015 plus 0.003 equals 0.0045. So next is as you can see, this number 2 here is the other way to get the total charge. So you could use these equations to get the exact total charge. So they are the same. It's up to you which one you would use to get the final charge of this parallel capacitor. So the fourth question is, how can we calculate the energy stored in C1? So we will use this equation to get the potential energy. So V equals 1 half CV squared. So it's 1 half times 100 times 10 to minus 6. That's the capacitance times the voltage across the capacitors, which is 15, then the squared. So this is equal to 0.01125 joules. So next is the series capacitor. So if we have a capacitor circuit in series, so we have here an example or a circuit example or a circuit problem that we would answer. So the first thing that we should look is the total capacitance of this circuit. So um, CEQ equals uh, 1 half, I mean 1 over C1 plus 1 over C2 plus 1 over C3. So to the power of negative 1. So equals 1 half plus 1 third plus 1 5 to the power of negative 1. So the answer is 0.9677 farads. So next is we have the first question, find the charge. So once you have uh, once you have the equivalent capacitance, the next thing you need to do is calculate the charge. So by calculating the charge, use this equation. By finding the charge, this will be a very helpful in finding each voltage in the three capacitors. So, which is the Q equals CEQ times V equals 0.9677 times 60, and we will get the answer of 58.7. So so that is the total charge in each capacitors. So now we're gonna find the how can you find, the second question is how can you find a voltage across each of the capacitors? So the first one, so we're gonna find the V1 is going to be Q1 over C1. So take the charge, which is the 58.7 divided by the capacitance, and make sure to add the 10 to the minus of 6. And then, so, 58.07 divided by 2 is equal to 29.1 volts. Next is the voltage across V2 is going to be Q2 divided by C2. So it's going to be 58.07 divided by the 3, and then equal answer is 19.3 volts. And lastly, the third, so by getting the voltage of the last capacitors, the same way with the first and second voltage. So V3 equals, V3 equals Q3 over C3, then 58.07 divided by 5 equals to 11.6 volts. So we have to get the total voltage is equal to V1 plus V2 plus V3 is 29.1 plus V2 is 19.3 plus V3 is 11.6. So if you add this values, you should get 60 volts, which is equal to the voltage of the battery. So this is how we are going to know the correct answer. So let's calculate. Next is to calculate the potential energy of C2 as well as the C3 and C5. So it's going to be 1 half C times V squared, and then we have 1 half times 3 farads times 19.3 squared equals to 558.7 joules. So that would be the final answer of this capacitor.